An electric vehicle charging station typically requires a 40-amp breaker even if it draws only 30 amps. The higher breaker rating protects the wiring from overheating. An 80-amp sub-panel might be insufficient if you plan to add an electric vehicle charger, especially with other loads. Upgrading to a 100-amp or 125-amp sub-panel may be necessary. The National Electrical Code, or NEC, permits the use of 220 Romex, also known as non-metallic sheet cable, without conduit in specific scenarios. Local building codes, however, may have different requirements. In attic spaces, 220 Romex can be installed without conduit if it's adequately supported and safeguarded against physical damage. Within interior walls, 220 Romex is permitted without conduit when concealed behind drywall or similar approved materials. To locate specific NEC code sections, consult the official NEC document published by the National Fire Protection Association, or NFPA. An isolated circuit is a dedicated electrical pathway separated from other circuits within the electrical system. It's designed to power particular devices or groups of devices, such as computer equipment. Firstly, electrical isolation is important because it isolates computer equipment from other power sources, reducing the risk of electrical noise and interference. Secondly, power quality is improved since it maintains a stable and clean power supply for sensitive electronics. Thirdly, overload protection is provided because it offers dedicated circuit protection for computer equipment, which reduces the risk of circuit overloads. The necessity of an isolated circuit depends on the sensitivity of your computer equipment and the potential for electrical noise in your environment. If you own expensive or sensitive electronics, an isolated circuit can be beneficial. When installing electrical wiring, it is important to support it correctly. Cables must be supported according to the NEC. For example, non-metallic cable, also known as NM cable or Romex, must be supported and secured by staples, cable ties, straps, or similar fittings designed and installed so as not to damage the cable. Support should be placed within 12 inches of every box, cabinet, fitting, or other cable termination, and at intervals not exceeding 4½ feet along the cable run. Cables installed horizontally through bored holes in framing members are considered supported, and do not require additional support. When running cables through metal framing members, bushings or grommets must be installed to protect the cable from abrasion. The size of the subpanel is determined by the total load that will be connected to it. The load calculation includes lighting, receptacles, and any fixed appliances. It is important to accurately calculate the load to ensure that the subpanel is not overloaded. When calculating the load for general lighting, a minimum of 3 volt amps per square foot is required. For receptacle outlets, a minimum of 180 volt amps is required for each outlet. Fixed appliances are calculated based on their nameplate rating. After calculating the total load, a demand factor can be applied to account for the fact that not all loads will be operating at the same time. The demand factor is based on the type of occupancy and the size of the load. The NEC provides tables that list the demand factors for various types of occupancies. The overcurrent protection device, such as the circuit breaker or fuse, must be sized to protect the conductors from overheating. The size of the overcurrent protection device is based on the ampacity of the conductors. The ampacity of a conductor is the maximum current that the conductor can carry without exceeding its temperature rating. The NEC provides tables that list the ampacities of various types of conductors based on their size, insulation type, and insulation method. The grounding system is an important part of any electrical system. The grounding system provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The grounding system consists of a grounding electrode, a grounding electrode conductor, and equipment grounding conductors. The grounding electrode is typically a metal rod or plate that is buried in the ground. The grounding electrode conductor connects the grounding electrode to the neutral busbar in the service panel. Equipment grounding conductors connect the metal enclosures of electrical equipment to the grounding system. When running Romex through attic spaces, it should be protected from physical damage. This can be achieved by running the cable through conduit or by installing running boards to protect the cable from being stepped on. It is also important to ensure that the cable is properly supported and secured to prevent it from sagging. When running Romex through walls, it should be protected from nails and screws. This can be achieved by installing metal nail plates over the cable where it passes through framing members. It is also important to ensure that the cable is properly supported and secured to prevent it from being pulled out of the box. An isolated ground receptacle is a type of electrical receptacle that has a separate grounding conductor that is isolated from the normal equipment grounding conductor. This type of receptacle is typically used for sensitive electronic equipment that is susceptible to electrical noise. The isolated ground receptacle provides a cleaner ground connection, which can help to reduce electrical noise and improve the performance of the equipment. When installing an isolated ground receptacle, it is important to use a dedicated circuit that is not shared with other equipment. The circuit should also be properly grounded to ensure that the isolated ground receptacle is effective. Electric vehicle charging stations require a dedicated circuit. This means that the circuit should not be used to power any other devices. The dedicated circuit ensures that the charging station has enough power to operate properly and that it does not overload the circuit. The size of the dedicated circuit will depend on the charging station's power requirements. It is important to consult the charging station's specifications to determine the appropriate circuit size. The electric vehicle charging stations also require a grounding electrode conductor. The grounding electrode conductor connects the charging station's grounding system to the building's grounding system. The grounding electrode conductor ensures that the charging station is properly grounded, which helps to protect people from electrical shock. The size of the grounding electrode conductor will depend on the size of the charging station's service entrance conductors. It is important to consult the NEC to determine the appropriate grounding electrode conductor size. Here are a few important points regarding the sizing of conductors for electric vehicle supply equipment or EVs. The conductors feeding EVs must have an ampacity not less than 125% of the maximum current demand of the EVs. For example, for 40 amp EVs, the conductors must have an ampacity of at least 50 amps. This is to account for the continuous nature of EV charging. The NEC specifies various wiring methods for EVs, including conduit, cable, and direct burial. The wiring method must be suitable for the location and environment. The wiring method must also be protected from physical damage. EVs must be grounded in accordance with the NEC. The grounding system must be designed to protect people from electrical shock. The grounding system must also be designed to prevent damage to the EVs. The NEC requires overcurrent protection for EVs. The overcurrent protection device must be sized to protect the conductors and equipment from overloads and short circuits. The overcurrent protection device must also be readily accessible. It's important to consider voltage drop when sizing conductors for EVs. Voltage drop can cause the EVs to operate inefficiently or to shut down completely. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Electric vehicle charging stations are becoming increasingly popular, and it is important to install them safely and in accordance with the NEC. The NEC provides detailed requirements for the installation of EVs, and it is important to follow these requirements to ensure the safety of people and property. Article 625 of the NEC covers electric vehicle charging systems. This article provides requirements for the installation of EVs, including wiring methods, grounding, overcurrent protection, and control and protection. Section 625.1 Scope. This article covers the electrical conductors and equipment external to the electric vehicle that connect an electric vehicle to a supply of electricity by conductive or inductive means, and the installation of equipment and devices related to electric vehicle charging. Section 625.2 Definitions. This section provides definitions for terms used in Article 625. Some key definitions include electric vehicle, or EV, electric vehicle connector, or EV connector, electric vehicle supply equipment, or EVs. Section 625.9 Supply Equipment. The electric vehicle supply equipment shall be supplied by an individual branch circuit. Section 625.15 Location. Electric vehicle supply equipment shall be located so as to minimize the risk of physical damage to the equipment. Section 625.19 Wiring Methods. All wiring methods shall comply with the applicable requirements of Chapter 3. Section 625.22 Equipment Grounding. Exposed non-current carrying metal parts of electric vehicle supply equipment shall be grounded in accordance with Article 250. Section 625.23 Disconnecting Means. A disconnecting mean shall be provided in accordance with 625.23. The disconnecting means shall be readily accessible and capable of being locked in the open position. The NEC provides requirements for the installation of EVs in dwelling units, commercial buildings, and industrial facilities. The requirements vary depending on the type of occupancy and the size of the EVs. It is important to consult the NEC to determine the specific requirements for your installation. In addition to the NEC, there may be local codes and regulations that apply to the installation of EVs. It is important to check with your local building department to determine the applicable codes and regulations. Ignoring the NEC code can lead to serious consequences, including electrical shock, fire, and property damage. It is important to follow the NEC code to ensure the safety of people and property. Electric vehicle charging stations are a growing part of the electrical industry, and it is important to understand the NEC code requirements for their installation. By following the NEC code, you can ensure the safe and reliable operation of EVs. When working with electrical systems, it is important to always take safety precautions. Some of these precautions include wearing safety glasses, wearing rubber gloves, and using insulated tools. It is also important to turn off the power to the circuit before working on it. By taking these precautions, you can help to prevent electrical shock and other injuries. When upgrading a subpanel, it is important to consider the size of the existing service entrance conductors. The service entrance conductors must be large enough to handle the increased load of the new subpanel. If the service entrance conductors are not large enough, they will need to be upgraded as well. When running new circuits, it is important to use the correct size wire. The size of the wire will depend on the ampacity of the circuit. The NEC provides tables that list the ampacities of various types of wires. It is important to use the correct size wire to prevent overheating and electrical fires. When making electrical connections, it is important to use the correct type of connectors. The type of connector will depend on the type of wire being used and the application. It is important to use the correct type of connector to ensure a safe and reliable connection. When installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on how to install the equipment properly and safely. It is important to follow the manufacturer's instructions to prevent damage to the equipment and to ensure safe operation. When working with electrical systems, it is important to be aware of the hazards involved. Electrical shock can be fatal. It is important to take precautions to prevent electrical shock. Some of these precautions include wearing safety glasses, wearing rubber gloves, and using insulated tools. It is also important to turn off the power to the circuit before working on it. When upgrading a subpanel for an EV charger, a load calculation is critical. You need to determine the existing load on the main panel, the load of the existing subpanel, and the additional load of the EV charger. The EV charger load should be calculated at 125% of its nameplate rating, as EV charging is considered a continuous load. If the total load exceeds the capacity of the main panel, you may need to upgrade the main panel as well. The ampacity of the conductors feeding the subpanel must be sufficient to handle the load. The NEC provides tables for determining the ampacity of conductors based on their size and insulation type. The conductors must be protected by an overcurrent protection device, such as the circuit breaker or fuse, sized appropriately for the conductor ampacity. The subpanel must be properly grounded. The grounding system must comply with the NEC requirements. An equipment grounding conductor must be run with the circuit conductors to the subpanel. The equipment grounding conductor must be connected to the subpanel's grounding bus and to the grounding electrode system at the service entrance. Surge protection is recommended for EV chargers. Surge protection can help to protect the EV charger from damage caused by voltage surges. Surge protection devices can be installed at the main panel or at the subpanel. Before starting any electrical work, it is important to obtain the necessary permits from the local building department. The building department will inspect the work to ensure that it complies with the NEC and local codes. The electrical work can be dangerous, and it is important to hire a qualified electrician to perform the work if you are not comfortable doing it yourself. A qualified electrician will have the knowledge and experience to perform the work safely and in accordance with the NEC and local codes. The electric vehicle charging stations are a relatively new technology, and the NEC requirements for their installation are constantly evolving. It is important to stay up to date on the latest NEC requirements to ensure that your installation is safe and compliant. Consider the location of the EV charger. It should be located in a convenient location for charging your vehicle, and it should be protected from the elements. The EV charger should also be located in an area that is well lit and accessible. Choose the right type of EV charger for your needs. There are several different types of EV chargers available, including Level 1, Level 2, and DC fast chargers. Level 1 chargers are the slowest, and they can take up to 20 hours to fully charge an electric vehicle. Level 2 chargers are faster, and they can fully charge an electric vehicle in about 4 to 6 hours. DC fast chargers are the fastest, and they can fully charge an electric vehicle in about 30 minutes. Check the compatibility of the EV charger with your electric vehicle. Not all EV chargers are compatible with all electric vehicles. It is important to check the compatibility of the EV charger with your electric vehicle before purchasing it. Read the installation instructions carefully. The installation instructions will provide detailed information on how to install the EV charger safely and properly. It is important to read the installation instructions carefully before beginning the installation process. If you are not comfortable installing the EV charger yourself, hire a qualified electrician to perform the installation. A qualified electrician will have the knowledge and experience to install the EV charger safely and properly. Following these tips can help you to install an EV charger safely and properly.